This video is going to review kinetic energy and the kinetic energy equation. Kinetic energy is the energy found in moving objects. You can also look at the particles that make up objects, and if they're heated to a high temperature, the particles that make up things will also move at a quick pace or high kinetic energy. So this is the equation for kinetic energy. Kinetic energy can be found by taking 1/2 the mass of an object, multiply that by its velocity squared. Now we know that if an object is moving, that would have some value for velocity, which is what's going to help us to find the kinetic energy. Now, when you find energy, the unit that you find is something called a joule. And a joule has the value of kilogram times meter squared divided by second squared. And we'll see that when we show you the sample problem on the next screen. This is the sample problem from the textbook. It states a jogger with a mass of 60 kilograms is moving at a speed of 3 meters per second. What is the jogger's kinetic energy? So let's see how we can plug this into the formula and find out the value for kinetic energy. As with any problem, it's important to write down the known variables. So in our problem, we have mass, which is m. We have v for velocity or speed, and the kinetic energy is the thing that we're looking for. So the mass is 60 kilograms. Always write down our units of measurement, and the speed is 3 meters per second. All right, the equation we're going to use is up in the upper right hand corner here. So we're going to use kinetic energy is equal to 1/2 the mass times velocity squared. Now when I solve for this, I like to keep the 2 in the denominator, so I'll divide my final product by 2. So mass is 60 kilograms, and my velocity is 3 meters per second, but that whole value needs to be squared. So I get 60 kilograms times the 3 squared. It says 3 times 3, that'll be 9. And meter squared over second squared. The whole value in the parentheses gets multiplied through, divided by 2. So if you take 60 times 9 divided by 2, you end up with the value of 270. And our units would be kilograms times meters squared over second squared, or 270 joules. We found joules, which is the value for kinetic energy, so we just found the value for the jogger's kinetic energy moving at that velocity.